Hey guys, how's it going? Here we are back again for the Python BACnet Stacks Playground. This video might just be a little bit on the shorter side today, but just let's take another crack at it. Um, okay, so last couple videos we talked about Streamlit application. Check the older videos on what Streamlit is. It's kind of what we're using to vibe code this new and improved so basically, we're kind of just making a fault detection application that can analyze document deficiencies in the HVAC system. It has a full-blown software engineering agentic AI specification. So any software developer people or IoT people, just aim your agent at the agent's MD, and it'll go right into this agent spec on how this Streamlit application is put together. If you want to wire it into your SQL server or your data lake or whatever, you should be able to do that with ease. I'm also using this to retrofit the actual Open-FDD project that isn't ready yet. That's getting rewritten in Rust, so take advantage. Okay, so we had some bugs yesterday. I have some updated Docker containers. So I am pushing regular Docker container updates to here. This is a GitHub container repository. Um, so you can publish Docker containers to GitHub, which is kind of nice. Um, this is something I'm going to play around in the future, but you can also publish Docker containers to Docker Hub. So this is what NREL does, is they have Energy Plus, where you can just Docker run, and it will pull the latest and greatest Energy Plus Docker container from Docker Hub. In LBNL, it looks like they have Energy Plus model context server. So this is also something to, it looks like they don't have a GitHub package, but I think there is actually a Docker container for this. Anyways, I have been experimenting with this. So this will be actually, this will, sorry, jumping around a little bit. So like where I was showing this Energy Plus and LBNL model context server, this will be coming next on Vibecode app 20. So this is what I'm shooting for is just direct analytics, fault detection data, right, pump it right out of Open-FDD. In the Streamlit application is the one at the moment that's the latest and greatest. Then I want to see if I can use Energy Plus and the AI agent to piecemeal together a savings for the building. So basically the AI agent would be putting together an energy simulation for the building if you have enough data, which would include utility records and then also some architectural records you would need. But we're not going that far for the building 100. I've been demoing. I've just been doing basically just a retro commission style of documenting deficiencies that I'm noticing. But I think we should be going as far as doing energy calculations and making the tool robust enough that if you have a really good local utility rebate program, um, that we can build a good enough report, do some energy calculations, and cut a check to your client basically. So some of this stuff could add up to depending on where the utility rebate program is located. Some are better than others. You could get a nice rebate check for your client. So it's coming. I think I might have on this next building, I want to demo possibly enough data to do that. But there are some caveats too. So let's just get back to where we left off yesterday. So Vibecode 19. So this is the GitHub container repository. And like I was showing with NREL, they publish their containers to Docker Hub. You can I'm publishing my stuff just at the moment to GitHub Container Repository. It's just easier and cleaner for me. So this was just published 13 minutes ago. Let's give it a whirl. So we're just going to kind of run this command right here. It has a tag for the latest. So if I just go, let's just go back. If you go in here into the vibe code app 19, and let's just pull the latest and greatest containers. So basically you just have to go to here. So steps by hand. I'll have to clean this up too because I'm not really using this at the moment. I'm just doing like this pull the container by hand. Okay, so you should be able to do this all locally on your Windows computer. If you like, I have Docker Desktop on my Windows computer, but I've just been kind of playing around with this. My old Windows computer that is just a little Linux server on my test bench. I run Ubuntu server on it, but you could do this on Raspberry Pi too. If you have a Raspberry Pi 5, oh, whoops, geez. So still in PowerShell and Windows, I'm gonna close out of that. So I have to SSH into my server first. Okay, now I'm in Linux world. Just clear you. So Ben's bench, that is my Linux computer. Okay, so this is pulling the latest and greatest container from GitHub container repository. And hopefully soon in the future, we can play around with, these videos are getting like a little bit more drawn out than I thought they would, but we can do some energy calculations. So long-term idea is like this would be like an IoT application, and you can do CSV data file analysis stuff. If you have an IoT provider right now, bulk pulling CSV data from their API would be something of interest. And then you can just run this tool locally on your test bench or even your same computer. And then we can dial into it. Okay, so like we started this Docker container, Docker PS. Looks like we're up and running. And then we just dial into it on port 8502. So I'm just going to, these are my GitHub issues from yesterday. Okay, I'll just dial into it on this one. So I have this like dialing into locally on my network, the Streamlit application. The next building that I'll go through, I will demo again how to get weather data from openmedio.com. That is a weather service where you can bulk download historical weather data for free, which is really super useful when comparing web weather, historical web weather, to the local building automation sensors, which are always really flimsy and read poor values. So let's just open these guys up. In the next building too, I will demonstrate a little bit more detail. I have been using Cursor locally. Any AI tool would work, Claude or ChatGPT, and all in here, back into the vibe code app 19. Just aim your AI agent. This is the spec to build it, to build the software application, but it'll know what to do on how to label the data. Maybe let's see if I can demo this real quick. But let me just navigate another monitor here. Something doesn't quite look right. Sorry, guys. Maybe this is good enough. But there is some little JSON files in here, which we'll get into more details later. But these are like just a column mapping. So the raw CSV data in here. I bulk downloaded it from the client, and then I also use my own AI tool to it's the way that the Streamlit application is working on the back end. It's hard coded JSON mapping for raw CSV column names to haystack name. So it's just like a key JSON key and value. I'm not at the moment doing like a full blown haystack RDF resource description framework, like digital twin, like a full blown data model. It's maybe I will in the future if some people can talk me into if I need to do a full blown RDF model for kind of one building at a time. I can see how that would be useful if I had hundreds of buildings that I was running these fault detection equations across. But I feel like when I do this stuff, I'm so cued in on one mechanical system at a time that it's I for me to get the useful insight out of it, these buildings, I'm just very zeroed in on one building. And this JSON keys and value manual mapping is working good enough for me, I think. So I can basically create this JSON based haystack ish data model, and then it'll automatically run rules across the entire data set for rules that apply to this type of system. Um, so we could do RDF maybe someday in the future, but I just think that is kind of a little overkill for what I need at the moment. It just adds more complexity. But I'm real curious if anyone could enlighten me on that. It's like RDF framework for anyone is it's like the advanced data structures. So like in the smart building industry, there are PhD computer science people that have also gravitated towards the HVAC industry, and what they brought with them was they probably studied in their graduate coursework is how search engines work on the internet. Like Google, there's keywords that you enter in for a Google search, and then that is like an very high performance, advanced knowledge graph based query. So really big data sets, for everything made on the internet, and it's like computationally efficient and everything like that. Um, like until I had like a data set that big, I'm just not sure if I need the complexity to do that quite yet. But uh, that's not my specialty. I'm not a computer scientist, so um, I'm open for debate. So I'm just doing key and value mapping, nice little JSON file. Maybe it's good enough. It seems to be working right now. So DM me on Discord or drop a comment. I'd love to know. Okay, so here we are. We're in here, still working on this. So load the zips. Apologize, this is going to be kind of a short video again today, but maybe I can just show you some more of the features we fixed yesterday. Little triathlon guy is working up here in the corner. So this is part of Streamlit applications is they have like this little triathlon looking guys running, swimming, biking. And as soon as he stops, that means like the Streamlit application is no longer processing data. So one thing I did do is this building, we've looked at it a little bit before. Let me just pull up on a monitor. Is some of these videos are getting awfully redundant, which I apologize for. Um, it's like taking about 10 times longer than I thought, and then I keep on like doing the same material over and over and over, and like just inching along every video. So this is our air handling units for this. It's a 6-story office building, upper Midwest, USA. Really hot, humid summers with weather out of the Gulf of Mexico that's like really humid every summer. It's really humid right now um, outside and hot, and then really cold winters. So like a couple intense months in the summer of like high humidity, high requirement for cooling, and then in the summer or in the winter, it's flip-flopped. It's just completely manic weather patterns of like, very cold, below freezing, and frozen lakes, lots of snow. So it's just it's not a very like it's not like a stable uh, weather climate. Perhaps maybe like England or Europe, or the west coast of the United States. It gets kind of squirrely where we are. Tornado Alley, So, okay, so this is these okay, so 6-story office building. I'm learning about this building as every video I make too. So, 150,000 square feet of conditioned space, 6 stories, 2 air handling units with I know we're just looking at a schematic, but I'm learning that these are monsters. Pretty big fan systems here. So up to 100 horsepower, I think some of these fans might be. So that's a big fan. Um, Pushing air up and down, I bet 6 floors. For some reason, I only have 40 VAV boxes of data, which might not be very complete. So I'm not doing a complete VAV box level analysis, but like, um, so I think these are roof mounted air handling units, big guys up on the roof, just cooling coils, no heating coil. And I think that I'm noticing in the data that there's no economizing at all. Um, I think, I wonder where my little mouse icon was. Mouse icon went away. So if I go here, okay, there's my mouse icon. I think this used to be, I would be willing to place money that this little box used to be this point for a minimum outside air position for the air handling units. We have a duct static set point of 1.56 inches of static pressure. That's right here. So there's a PID controlling this fan, maintaining a pressure sensor that would be 2/3 the way down the duct stream, needle in a haystack type sensor in here if it were to fail. Um, and then a discharge air set point of it. I think I noticed in the data it's 50 degrees, which is another thing that seems really off to me. Um, so two things I think I'm finding in this building is like the economizers have been disabled. They use the air cooled chiller starting at about 40 degrees outside air temperature. Um, and the energy saving strategy that I think I'm finding is it would be the most ideal scenario is fixing these economizer dampers and trying to put this. Let's see if I can find the chiller one. These schematics, they make it look like it's just like a really piddly little, just teeny little things, but these actually might be big machines. They're just like very small little schematics. So I kind of thought like when I first saw these, like these were just a little rooftop unit or something. But fans approaching 100 horsepower, those are big fans. Um, and these air cooled chillers might be pretty decent size too. And I think I'm learning that they are designed to run in tandem, so they're not redundant, which is another thing. I'm not a HVAC design person, but I think they do design buildings for n-1 cooling capacity, that if a chiller fails, that there is something redundant. So there might be some redundancy built into that, but from what I can gather, that there might be these chillers might be designed to run in tandem. And here there is an outside enable set point of 55 degrees, which isn't too bad. What I want to do for energy savings calculation is bump this up to 60 and see if if I can confirm what is broken in the system, that these economizer dampers don't work. The energy saving strategy would be to use free cooling up to 60 degrees Fahrenheit and then try and start a chiller. I have a feeling that the building operators that have ran this building have there's reasons why if this if these economizer dampers are in fact fixed and they don't use free cooling anymore, there's a reason for that. Like some maintenance staff has ran into issues with the building, and they probably just say, screw it, we can just run these systems in recirculation air mode. And like some maintenance staff, they don't see the utility bills. The accounting department sees the utility bills. We don't have to pay the bills. If anything, I'm going to make this system optimized for temperature control complaints, because that's what I'm graded on. I'm not graded on paying the utility bills. The accounting department does that. There's no incentive for maintenance building operators to fix the building for an energy efficiency way of doing things. It's always temperature comfort complaint driven. So if there were some band-aids applied to this building, I would be willing that 99.9% of the time, 0.99999, it is some band-aid on a temperature control problem, and they don't care about utility bills. Accounting department pays for that. But if there was, I sometimes joke around about this, if there was that one crazy idea that what if maintenance staff were incentivized to care about utility bills, then, I've always wondered this, I mentioned this once, that how cool would it be that if a maintenance facilities management program had something in there for every fan run hours reduced to bare minimum run time. Here's a Walmart gift card. Here's a gas station prepaid debit card for $20. Something. I guarantee it would go a long ways if maintenance staff were incentivized to, from a building fuel use standpoint, optimize the system. That's just my opinion, but I'm sure it's a lot more easier said than done from a management standpoint. I don't manage people, so that aspect of managing people is probably a lot harder than in what I'm preaching. Okay, so let's get out of this. I need to just move this along a lot further and faster. But okay, so like we've looked at this several times. This data set is from starts in March, ends in July 3rd, 2000 hours, 2,600 hours. At the moment of this application, we set the comfort range of the building. This is by the client, is they have to maintain 72 degrees per their leasing agreement for their tenants between these hours of 6 a.m. to 5 p.m. Monday through Friday. And then on Saturday, they have to go. There is actually one requirement in here too. A Streamlit application runs every time I push a button here. So, but on Saturday, from actually this is 7. Come on, little triathlon guy, go fast. So what happens at the moment? There has been some computation bottlenecks in this application where things are a little bit more per button driven to make calculations rather than crunching numbers all at once. I actually used a Fable 5 model to optimize the application from a computational standpoint. Can probably do a way better job than I can, but I can probably give it a run for the money in spotting fault detection. So that's where I'm going with this. I still don't think, this is my own another opinion here too, that I had high hopes that I could give AI enough like faults and it could find stuff wrong in the building but I'm kind of walking back on some of this stuff. It's like, I think the biggest piece of this is the human really diving into the faults and really validating. Yes, this like I'm trying to validate the crud out of these buildings, and like I have, just skeptical of AI being able to do that, but like I feel like if I can provide good data that yes, these are legitimate fault hours, and then I have more trust, probably because I have less work experience in this, but using so like I can like what I'm shooting for is to carve out enough analytics and things wrong with this building data that pump out some kind of a file and then give that to the AI agent that can fire up Energy Plus and the Energy Plus model context server. And it can go, I iterate through kind of making, a digital twin physics model of this building. And then if I had some utility bills, it can kind of calibrate that model and try and best, make a digital copy of it. I feel better that the AI agent will perform better at that than it will looking at some of this stuff because originally I didn't, it wasn't working very well. Okay, so this is this bare minimum runtime hours here that we've looked at before. This little dashed line, it's probably hard to see. Gray line, that's the original run hours set by this schedule, 67 hours a week. We talked about how maintenance staff in building automation contracting, they'll continuously manipulate this runtime schedules on the actual building automation system that looks something similar to this, but this is outside air temperature. So like some of the guys will just adjust manually, really cold weather in winter, so they adjust for really long run times, and then really hot weather, like we have weather extremes right now, and they'll override the building 24/7, which is totally fine and acceptable for these weather extreme events, both hot and cold. Is that we keep the building comfortable, and it's pretty common. It's probably a good thing to do for extreme winter and extreme hot is just run things 24/7. Hopefully you can back down on the amount of outside air you're conditioning. But then in between, the vast amount of in between shoulder seasons is when sometimes they forget that they overrode that, and then pretty soon you have months and months of runtime with some equipment running 24/7 that was set way back in January when someone forgot to click the override off. So that's why we have two separate mechanisms to validate that. Boilers dropping off here. Still have to ask the client. It appears that they don't do any reheat in the building, so if I would expect to see warmer discharge air temperatures on the air handling unit to not overcool zones. Chiller run hours really pick up as summer progresses, and I do even have some recorded weather, 60-degree average even in March, which seems really warm to me for the building location in Fahrenheit. And all of this weather data is also coming from openmedio.com, which is the web weather. So this is what I'm trying to make as my energy ECM is. It's not much data or much energy. It's 100 hours of runtime for the chiller plus 36, 100 and say like 140 hours of runtime from the chiller, probably at kind of low loads when this could be free cooling. If it is a big chiller, that could be something that we could equate right to monetize it. I do have a calculation too that I'm doing outside our dew point too. So that's my previous employment and just doing algorithms we had a couple of really old buildings that were school districts, and one of the other engineers came up with a strategy to, instead of using return error enthalpy, economizing decisions, because these sensors were existing way beyond 5 years, or what the original manufacturer had calibration for return air humidity sensors and outdoor air humidity sensors local to the building, which are really notorious to being out of calibration. We decided to go off of outdoor dew point as a economizing determination. So we came up based off of weather station web dew point. If the web weather dew point, if the outdoor dew point in degrees Fahrenheit is below 60, and the outside air dry bulb is below 72, we were calling that a, we can economize. And it worked really well for shoulder season months when the dew point was really low, but the dry bulb could be really high. So basically, if the dew point is really low because there's not a lot of humidity around in the shoulder season, we could basically economize all the way up to return air of the building in dry bulb. So 72 degrees. So that was a dew point, outdoor air dew point determination. So this is built in here too. Okay, so this is dry bulb. So this is web weather versus local weather. This chart is fixed for our issue yesterday. Oh, cool. Oh, neat. So sometimes the AI, when I ask it Fable or something to fix a few things, it even does stuff a little bit more than I even asked it for. So like this chart, 5-degree deviation is where we do a fault. This tolerance here, plus or 5 tolerance. So there, we just know that local and BAS local in web weather dry bulb, it could read 81, and then here we're at 75. So there is some drifting here and there throughout the day. Instagram, which we've studied before. Okay, so then this is this raw data. Wow, there's a lot of raw data. So it looks like we do have VAV space temperatures, a lot of flatlined data. Flatline data. So I'm just kind of looking through here. This is a new chart I added to just investigating. Just kind of look once over on this kind of raw data before we feed it into the machine. Air handling unit 1, air handling unit 2. Fortunately, I have to go soon, and there's just hardly anything. I think this stuff takes time, though, to really do a good job at this, even with a tool to help you organize the data, run some faults across the data. A building like this size, if you really want to do a good job without even getting into any of the energy calculations, assuming you have clean data, like 10 hours minimum, and then 20 hours would be probably a luxury. Okay, so what I wanted to look at is what we were looking at yesterday is this minimum position on the air handling units. So if there's one thing I can actually do today, it's just like validating that these that this is reading 100 on some of the charts I was looking at yesterday, which looks extremely unusual, but it's showing up as 0 here. So it's either 100% closed in the data or it never opens. Yeah, so many zone temps are just all over the map. A couple broken zone temperature sensors. I don't think I have enough data to get really into the weeds on individual component level. Minimum position. Oh, it does have it. So it's 20. So they do have a minimum position set point. Mixed air temperature. Mixed air damper command. And they do have like a. Okay, so we must have the wrong point to map through then. So sometimes it's 0, sometimes it's 20. So this looks good. Plotly. So MADC PCT, mixed air damper percent. So that would track the set point right here, except if you're in some kind of economizing or something. So I'm putting a blessing on air handling unit 1 or 2 is fine. So let's just check out air handling unit 1. Another thing we saw yesterday too is that the duct static pressure was really quite big on this other air handling unit too. And then I actually have to call it quits for today. So sorry if this video is not very long, but it's getting there. Stuff is time consuming. Okay, so MAD command, I'm saying that is our. Oh, okay, so like I am walking back, and I was saying that this sensor, this is probably the box where this minimum outside air position of 20%. It looks like they still have it here in the BAS. They just don't have it on the graphic, which is probably a good thing. And I could see in the data that it is actually doing something. Yep. So if you see right here, 90%, it's doing things. They are actually doing something. Gosh, so why do they need the chiller then to run at such cold outdoor air temperatures? We might just have to put together some very generic plots, I guess, of some of these conditions to compare return air temperature and outside air temperature. Anyways, this is all I have time for today, guys. So baby steps, little by little, and we can start doing some cool things. Hopefully we can even do a couple cool things all the way to if we find some really radical things wrong, doing a few things in Energy Plus as well. So hope you guys are liking this, and I will see you guys on the next go round. Have a great day.